could factor out 4 of them. And that's what we did here. So one of those would be remaining right here. Then this had x minus 1 squared. This had x minus 1, so we could factor out one of those. Hey, how can I help you? Okay, let's complete the square when a equals 1 for a non-factorable quadratic equation. I have made this problem x squared equals 3x minus 9. Just like before, we need to make sure that all of our variable terms are over on the left side and our non-variable terms are on the right side. Right now, our negative 9, there's our non-variable term. It's on the right side already. Haha, the right side. But our 3x is not, so we subtract 3x from both sides. And now we have x squared minus 3x, there'll be a something, equals negative 9. To figure out what that something is, we complete the square. So we divide negative 3 by 2. Now, if negative 3, or if that b value was an even number, this would divide evenly. But it's an odd number, so that means that we are going to have a fraction here. No need to fear. It's just that we can't simplify that any further, so we just square it. And then negative 3 squared is 9, 2 squared is 4, so we add 9/4 to this side, and we also add, add 9/4 to this side. Oh, you'll notice I'm gonna have to add these. I just threw a 1 under it because everything is being divided by 1 all the time. Everything, always. Just like everything's being multiplied by 1. All right, so now let's go ahead and start adding these together before we come back to this side. I gotta simplify it. If I want to add 2 fractions, that means I have to have a common denominator. So I would multiply negative 9 over 1 by 4 over 4. That gets me 36 over 4, negative 36 over 4, plus 9 over 4. And now when I add those together, I get negative 27 over 4. And then I can rewrite the other side of the equation like that. Okay, next step, I'm going to crunch this down. I'm going to make it into a binomial. And in order to make it into a binomial, I know that this is a special factor. How is it a special factor? Because I literally squared this value. I literally divided this by 2 and squared it. So I've made myself a special factor, which means that this value right here is exactly what's going to go inside of my equation. There's my little binomial, all done. Oh, well, we're not done, but I've crunched it down at least. My next step would be to take the square root of both sides. Now that's nice because over here we just get rid of that square and we're left with x minus 3 over 2. But this guy right here, oh man, it's going to be a lot of fun work for us because we have to use a couple of rules in order to simplify it down. I know a lot of you argue, why do I need to know all these rules? Well, they're math rules. And even though this is an imaginary number, and we know it's going to be an imaginary number, it's always good practice to be able to use all of the rules that we have in order to evaluate a number and simplify it completely. So if we are going to simplify it, allow me the use of arrows. Woo! We're going to go up here. So we've got the square root of negative 27 over 4. The first thing I'm going to do is I'm going to use the quotient rule for radicals, which says that I can rewrite this as the quotient of a square of square roots rather than the square root of a quotient. So now that I've written it this way, I can simplify each side of the line, or each part of my quotient, in order to simplify it. So up on top, I can rewrite this first as positive root 27 times root negative 1. Notice there's the negative right there, so I was able to split those apart. And of course, the value on bottom will just simplify to 2. Ah, dang, I ran out of room. So let me bring this down right here. Now, root 27, I can simplify that even further using the product rule for radicals, which means that I can write this as root 9 times root 3 times root negative 1 all over 2. And then that will simplify completely, or it won't simplify completely, but it will simplify. And I'll have 3, because root 9 simplifies to 3, times root 3 times I. That's how I can write root of negative 1, and that's all over 2. And of course it's plus and minus because I took the square root originally. Whenever I take the square root, I have to remember that I can get both a positive and a negative from that answer. So if we go back to here, so now that I've simplified this, I can write it as 3 root 3I all over 2, plus minus, don't want to forget the plus minus. And then my last step to get x completely by itself, I would add and subtract 3 halves on both sides, those cancel, so that x is equal to 3 over 2 plus or minus 3 root 3I all over 2. You'll notice that even though this is the final answer, I did not express this over one denominator because of course this is an imaginary number and this is a real number, and we always write complex numbers in a plus bi form, where a is our real portion and bi is our imaginary portion, and together it is a complex number. So together this is a complex number. This is the real part and this is the imaginary part. And that's our answer. Okay, now we're going to complete the square when a does not equal 1, and this particular example will be factorable. Please keep in mind, the main goal of completing the square is to get x by itself when we are trying to find the roots of a quadratic. When we're trying to find for what input will the output be 0. We want to know what numbers do we plug in to get 0 out. That's the goal. So we're solving for x by itself. There's a couple of extra steps here. I'm going to do my best to speak clearly and make sure that I'm saying all the steps correctly, but I guarantee I'm going to fumble over the words once or twice, so, you know, have patience. Stick with me. We're going to get through this. You can do it. Okay, first things first. Let's move our non-variable terms to the right side of the equation. This leaves us with 2x squared plus 11x equals negative 5. Now before I can go completing the square, there's something very important that we have to do, and it has to do with this 2 right here. We have to factor out the 2 from this side of the equation. We aren't changing this side of the equation numerically, we're just rewriting it in a new form. We're factoring it, but it'll be the same as what we did before, so we don't have to factor 2 out over here. So when I do factor this out, I get 2 times the quantity, x squared plus 11 over 2x plus something. You'll notice that just because 11 wasn't divisible by 2, I had to factor out 2. So I'm left with a fraction right here. That is going to make everything more challenging, but we can do it. We follow the steps just like before. We just have a fraction involved right from the beginning. So yes, it is harder, but definitely doable. Now that we factored that out, we can begin to think about this something that has to go inside in order to complete the square. And in order to do that, we're going to complete the square just like normal. We're going to take our b value, which is 11 over 2, and we're going to divide that by 2. Haha, fraction of a fraction. A-okay, we can do this. Remember that we just multiplied by the reciprocal, and to do that, the bottom cancels out, and we are left with 11 over 4. This is the value that we square, and that gives us 121 over 16. So we write 121 over 16 inside. And of course, we have to add that to the other side. Again, this problem is different because we had to factor out that a value. So when we go to add it on the other side, we have to multiply it by this value here. So we'll be adding 2 times 121 over 16. All right. I'm going to put this little line right here because I'm going to be doing some work over here in order to simplify this. And once I'm done simplifying, then I can worry about both sides again. I'm going to start by writing negative 5 over 1. And then right here, 2 goes into 16 8 times. So I can simplify 121 sixteenths to 121 eighths. And now I just have one fraction again. From here, I, of course, need a common denominator, so I'm going to multiply negative 5 over 1 by 8 over 8, and that gets me negative 40 over 8 plus 121 over 8. And negative 40 plus 121 is positive 81 over 8. All right, we simplified it, we did it, and I love seeing a perfect square on top because that means, yes, it is going to be factorable. Now we come back to this side, we've got 2 times x squared plus 11 over 2x plus 121/16. Again, the whole reason we did this work right here is to get that perfect special factor. And because it's a special factor, that means we can crunch it down. And then when we crunch it down, what value do we use? This guy, the value that we squared. So we've got x plus 11 over 4 squared equals 81 over 8. You know, I could have divided this 2 off here. I could divide it off now. All that matters is that you definitely divide it off before you take the square root of both sides. So let's do that now. I'm going to divide both sides by 2. So boom, those cancel. Then over here I've got another fraction of a fraction. So I multiply by the reciprocal. And that gets me 81 over 16. And yeah, that's what I wanted too, because of course I want the bottom to simplify just as easily. And we don't have to rationalize the denominator. Oh no, you guys I know love rationalizing the denominator. We know that I love rationalizing the denominator, but I'm supposed to. Okay, now that we have the squared here, we can go ahead and take the square root of both sides. Let's take the square root. That gets us x plus 11 over 4 equals, okay, well, again, the quotient rule for radicals says that we can take the square root of both the numerator and the denominator individually. So that means that we're going to have plus minus 9 over 4. Our very last step is to subtract 11 over 4 from both sides. And so x is going to be equal to negative 11 over 4 plus 9 over 4, and negative 11 over 4 minus 9 over 4. Negative 11 plus 9 over 4 is negative 2 over 4, which simplifies to negative 1/2. And negative 11 over 4 minus negative 9 over 4 is going to be negative 20 over 4, which simplifies to negative 5. So that means my answer, x is equal to negative 1 over 2 and negative 5. Those are my roots. So it was a little bit harder because there was a couple more steps that we had to do, but it's basically the same process.